Alright, here's your guys' homework on rational root theorem, numbers 1 through 12. Alright, so for 1 through 8, you guys, is to state the possible rational zeros for each function. So what we have to do is remember this one is your guys' p-value, your constant term, right? And this one is your guys' q-value. So we have to find the factors of p and divide it by all the factors of q. So factors of -1 is pretty much plus or minus 1 and 1, right? And factors of 3 is 3 and 1. So those are factors, right? So now let's do p over q. And factors of p is just plus or minus 1, right? 1 times -1 is -1. Factors of q is 3 and 1. So I'm just going to do plus or minus 1 and 3. I like to do it in order. Now, we have to find all our possible rational zeros. So what we have to do is we have to divide every single p factor divided by every single q factor. So 1 over 1 is 1, and then 1 over 3. And those are all our possible rational zeros for this function. Plus or minus 1 and plus or minus 1/3. Number 2, so remember your constant term, even though there's degrees missing here, you guys, the constant term is -64, so this is our p, right? And this is our q. Now we have to find our factors of p, right? So 1 and 64, right? All factors of 64. 2 and 32. 4 and 16. Not 6, not 8, not 7. Not 9, not 10, 64. Am I blanking? Oh no, 8. 8 and, 8 and 8. And that seems to be it, right? So there's all our factors of 64, and factors of 1 is just 1 and 1. So when we make our p over q list, which is all our possible rational zeros, plus or minus all the factors of 64. So 1, 2, 4, 8, 16, 32, 64. We don't need to include twice. We don't need to include 8 twice. And then factors of q plus or minus 1. So there's our factors of p, and now we gotta divide it by all the factors of q. So 1 divided by 1. Plus or minus 1, 2 divided by 1, 2, 4 divided by 1, 4, 8, 16, 32, 64. So these are all our possible zeros, all our possible rational zeros. Number 3, here's our p, there's our q, that's a coefficient of 1. So all our factors of our p, so 1 and 10, 2 and 5. All our factors of q, just 1 and 1. So our p over q list is plus or minus 1, 2, 5, and 10, all the factors of 10, over plus or minus of 1. So 1 over 1, plus or minus 1, 2 over 1, 2, 5 over 1, 5, 10 over 1, 10. And those are all our possible rational zeros. So again, numbers 1 through 8, you guys, is just have you guys practice just getting all your guys' possible rational zeros. Alright, here, this one's p, this one's q. So all the factors of -8, or just, yeah, -8. So plus or minus, well, it's always going to be plus or minus. So plus or minus 1 and 8. 2 and 4. Now factors of 5, just 5 and 1. So we can make our p over q list. So So plus or minus 1, 2, 4, and 8. And plus or minus 1 and 5. Okay, so remember, you need to do all the factors of your constant term p over all the factors of q. So 1 over 1, 1, 2 over 1, 2, 4 over 1, 4, 8 over 1, 8. Now you gotta do 1 over 5, which is 1/5, 2 over 5, 2/5, 4 over 5, 4/5, and 8 over 5, 8/5. So those are all our possible rational zeros. Okay? Okay, number 5. So remember, p is your constant, q is the leading coefficient. Factors of 25, negative 25, 1 and 25, and 5 and 5. Factors of 4, 1 and 4, 2 and 2. So our p over q list, right? Our rational zeros list, or possible, we got plus or minus 1, 5, and 25, right? Factors of negative 25. Plus or minus for q, 1, 2, and 4. Alright, so factors of p divided by the factors of q. So 1 over 1 is plus or minus 1. 5 over 1, 5. 25 over 1, 25. Now we're going to do 1 over 2, which is 1/2. 5 over 2, and 25 over 2. And then we got to do 1 over 4, 5 over 4, and 25 over 4. So at any point it gives you guys duplicates, meaning if it was, say you already had 2 and then there was another one that was 4 over 2, you don't need to include two 2's at the same time. You know 4 over 2 is 2, so you don't need to include that. Alright, 6. Constant term is our p, leading coefficient is q. Find the factors of both. So for 5 it's 5 and 1. For 21, 1 and 21, and 3 and 7. So our p over q list, all the factors of p, plus or minus 1, 3, 7, and 21. Factors of q, it's 1 and 5. So all our possible rational zeros, 1 over 1, plus or minus 1, 3 over 1, 3, 7 over 1, 7, 21 over 1, 21. Then we gotta do the other one. So 1 over 5, 1/5, 3 over 5, 3/5, 7 over 5, 7/5, 21 over 5, 21/5. And those are all our possible rational zeros. 7, p and q, that's a coefficient of 1. All the factors of 27, 1 and 27, and 3 and 9. Factors of 1, 1 and 1. Our p over q list, all the factors of p. So, plus or minus 1, 3, 9, and 27. Factors of q, plus or minus 1. So, our rational zeros that we found, we got 1 over 1, plus or minus 1, 3 over 1, 3, plus or 9 over 1, 9, 27 over 1, 27. And lastly, our constant term is 7, so that's our p, leading coefficients q. Factors of 7, 7 and 1, factors of 2, 2 and 1. P over q list, so plus or minus the factors of p, which was 1 and 7, factors of 2, 1 and 2. To find our possible rational zeros, so 1 over 1, plus or minus 1, 7 over 1, 7, and then you gotta do the other one, plus or minus 1 over 2, which is 1/2, 7 over 2, 7/2. And that's how you guys find your possible rational zeros. Now, 9, 10, 11, 12 is pretty much figuring out our possible rational zeros and then finding our rational zeros. So, for number 9, this is our P, this is our Q. So for P, we got factors of 3 and 1, and for Q, that's really a 1, so we got factors of 1 and 1. So our P over Q, our factors of P we found was 1 and 3, our factors of Q was 1. So 1 over 1 is plus or minus 1, 3 over 1, 3. So this is all our possible rational zeros. Now we have to guess and check to see if one of these is a rational zero by using synthetic division. So we're going to create our synthetic division, and we're going to write down the coefficients, right? So coefficient of 1, coefficient of 1, coefficient of negative 5, and coefficient of 3. So 1, 1, negative 5, and 3. So what we have to do is we have to think which one of these possible rational zeros will give us a 0 for our function. So I'm going to check out 1. So drop the 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 5 plus 2 is negative 3. 1 times negative 3, negative 3. Oh, and what do you know it? We found one rational zero, which is 1. Again, you are choosing from this list, right? There are 4 numbers you could select. 1, negative 1, or 3, and negative 3. And because this is x to the third, right, you guys? That means this is x to the second. It's 1 less than the highest degree in the original. And this is x to the first. It goes down by degree by 1 once you go from left to right. So we found 1, 0 of 1. Now what we can do is, I notice that this is a quadratic, right? Degree of 2. So we could factor oh yeah, 2 things that multiply to negative 3 is 3 and negative 1. 3 plus negative 1 is 2. So our factors are x plus 3 and x minus 1. So that means our x is equal to negative 3 and our x is equal to 1. And those are my remaining zeros. So notice, you guys, there is 2 1s, right? There are 2 zeros that are 1s. So what we can call that is, we found 1, but we call it multiplicity of 2. And multiplicity of 2, you guys, means there are 2 zeros that are the same number, which is 1. Okay. Now let's move on to 10. So remember, first we gotta find our P over Q list. So factors of negative 11 is 1 and 11. Factors of our Q value, it's 1. So our P over Q list, right? Factors of P was plus or minus 1 and 11. Factors of Q was just plus or minus 1. So then that, you guys, is just plus or minus 1 and 11. So again, we have 4 numbers we can choose from. Positive 1, positive 11, or negative 1 and negative 11. So it is a lot of guess and check. So just to demonstrate, you guys, oh, we gotta make our synthetic division. So that's a 1, negative 13, 23, and negative 11. 1, negative 13, 23, negative 11. Alright, so I'm going to just test out 1. So 1 times 1 is 1. Negative 13 plus 1, negative 12. Negative 12 plus 1. Negative 12, negative 12 plus 23 is 11. 11 times 1, 11, 0. I'm strictly just getting very lucky. I always like to start with 1 and negative 1, you guys, because I think those are the easiest ones to multiply and add. So now, so this is the power of 3, right, you guys? That means this one is 1 less than that. So x to the second, and this is 1 less than that, x to the first, and then x to the 0. So we really have this that we can factor and find our zeros. So 11, negative 12, two things that multiplied 11, but when added gives you negative 12. It's negative 1 and negative 11. So we have x minus 1. X minus 11 is equal to 0. That means x is equal to 1 and x is equal to 11. And I forgot to write it down, so our zeros was 1 from here, right? 1 from here, and then 1 from here. So 1, 1, and 11. Now, since we have two 1s, right, we can just simply say 1 multiplicity of 2, because there's two 1s that are zeros, and 11. And it's just completely guess and check, you guys. So here, P and a Q, right? Which is 1. Factors of 2, 2 and 1. Factors of 1, 1 and 1. Once you guys have your factors, put it over, do P over Q. Do I have space over there? Yeah, I have space over there. I'm going to put it over there. So all our factors of P, which is plus or minus 1 and 2. Factors of Q, which is plus or minus 1. So plus or minus 1 over 1, which is 1. 2 over 1, which is 2. So we have 4 options. Now let's use synthetic division to possibly find the rational 0. So 1, 4, 5, and 2, right? Those are your coefficients. 1, 4, 5, and 2. Okay, so drop the 1. So what number are we going to test from this list, right? I'm going to go ahead and try negative 1. 1 times negative 1, negative 1. 4 plus negative 1, 3. 3 times negative 1, negative 3. Negative 3 plus 5 is 2. 2 times negative 1, negative 2. Oh, that worked. And remember, this has a degree of 3, right? That means this one is 1 less than that, so x to the second, x to the first, x to the 0. And what do you know? We have a quadratic, right? Power degree of 2, so x squared plus 3x plus 2 equal to 0. We factor that out, you guys, so 2 and 3, which is 2 and 1. So our factors are, for that quadratic, x plus 2 times x plus 1 is equal to 0. So our zeros are negative 2 and negative 1. So we found a 0 of negative 1, right? We found another 0 of negative 1, and we found another 0 of negative 2. And remember, if you have two of the numbers that are the same, just like that, right? Negative 1, multiplicity of 2, because there's 2 of them. Okay, number 12, you guys, last one. This is our P, this is our Q. Factors of P is 1 and 5. Factors of Q, 1 and 5. So our P over Q list, you guys, is plus or minus 1 and 5, plus or minus 1 and 5. So 1 over 1 is plus or minus 1. 5 over 1, 5. Now we gotta do 1 over 5, which is 1/5, and 5 over 5. Now I'm not going to incorporate 5 over 5, you guys, because what is 5 over 5? 5 over 5 is 1, right? And we already have 1 in the list, so we don't need to include 5 over 5. So here's our possible rational zeros, so I'm going to use that list to hopefully find a rational 0 for this function. So remember, 5, 29, 19, negative 5, that's how you guys set up your synthetic division. Alright, so let's try some stuff out. If we did negative 1, let's just see what happens. So drop down the 5. 5 times negative 1, negative 5, add those together, 24. 24 times negative 1 is negative 24. Negative 24 plus 19, negative 5. Negative 5 times negative 1 is 5. And what do you know it? We found another one. So, that was a 0, so I'm going to lock it in. Negative 1 was a 0. Now, remember, this is a degree of 3, so that means this is 1 degree less. So 5x squared, and then x to the first, and then x to the 0. So look at here, we got a quadratic, right? Highest degree of this polynomial is now a 2. So we can factor this, right? We can factor this by grouping. On top, a times c is negative 25, on the bottom is 24. So we got 25 times negative 1. So when you guys factor this, 5x to the second plus 25x minus 1x minus 5. Right, this is factored by grouping, you guys. I can factor out a 5x from there to get x plus 5. I can factor out a negative 1 to there to get x plus 5. So we got 5x minus 1 times x plus 5 equals 0. So then your zeros are going to be 1/5, you guys, and negative 5. So that's why I told you guys, I trained you guys to be very good at your factoring. Being very good, because then it's just right away and it's just quick. So that is it. Make sure you guys get that practice in, especially the last 4 problems, and good luck, okay? Peace.